Hello, today we're going to walk you through a temperature benchmark test of a Raspberry Pi mounted in the innovative MaticBox case. As you can see, MaticBox has multiple openings on the 6 sides of the case that provide good ventilation. This video will start by comparing the temperature of a naked board with a board hosted in the MaticBox case during typical end-user tasks such as browsing the internet. It will then compare the temperature of the board with and without fans under 100% CPU load. Let's start with the thermal testing of a naked Raspberry Pi board under normal load. On the right side of the screen, you can see two terminal windows. The one on the top shows the CPU load, while the one on the bottom shows the CPU temperature multiplied by 1000. The test shows that during normal browsing, the temperature doesn't get higher than 60 degrees. If we start playing YouTube videos, the temperature will rise up to 73 degrees, but it wouldn't get higher than that. Let's mount Raspberry Pi into a MaticBox case. As you can see, this can be accomplished without disconnecting any of the cables. Now back to running the tests. During browsing, there isn't much of a difference in the CPU temperature. Keep in mind that this video is sped up, and in real time the processor temperature rises slower than the one in the video. When watching YouTube videos, we notice a 2 degrees increase in the temperature compared to a naked board. This is quite normal, since no matter how many ventilation slots a case provides, it is still a case, and it limits the natural airflow around the board. For the subsequent tests, we will utilize the specially developed MaticControl Application, which will allow us to set the processor load time, and monitor the processor temperature. Let's start with 100% load for 10 minutes. The thermal camera shows that the hottest area is the one between the power supply and the processor. It is just a matter of time under such load for the internal temperature to reach the critical 83 degrees. We can see that the naked Raspberry Pi board reaches this temperature in about 7 minutes. At this point, Raspberry Pi begins to throttle down its CPU frequency to protect itself from overheating. So, with a naked board, no active cooling, and under 100% load, the question is not whether the temperature will reach critical levels, but when it will reach these levels. When the same test is conducted with Raspberry Pi board inside the MaticBox case, the CPU reaches 83 degrees in about 7 minutes as well, which shows that MaticBox does not substantially limit the natural airflow. On the thermal camera, we can see the temperature of the different regions. The hottest area is the surface of the CPU, registered at 60 degrees. We have let the processor cool down for 20 minutes, and after that we've added a fan. There are two ways of adding a fan. The first one is to click it inside the case's body. In this case, the fan is oriented in such a way so that the air is pushed towards the processor. This is a more effective way of cooling, but the drawback is that it also pushes dust particles into the processor, and the board needs to be cleaned from time to time. We can see that with 100% load, the temperature does not get above 57 degrees, which is quite far from the critical 83 degrees. This shows that even this 500 RPM fan is perfectly capable of cooling the board. For our next test case, we've turned the fan the other way around so that it pulls hot air from the CPU and pushes it outside of the case. In this case, the internal temperature reaches 60 degrees, which is 4 degrees higher compared to the previous test. This is because the fan orientation results in a weaker airflow around the processor. Still, the thermal camera shows that MaticBox remained at room temperature, since the hot air is being pushed out of the case. Also note that once the processor load drops, the slope of the cooling curve is significantly steeper compared with the test without a fan. The second way of attaching a fan to MaticBox is by using the included fan adapter. The adapter provides enough space so you can add a heatsink if desired. For this test, the fan is mounted so it blows air towards the processor. As you can see from the temperature curve, the test does not differ from the previous one, where the fan was directly clicked into the case's body, and processor temperature is maintained again at 55–56 degrees Celsius. When the fan is clicked directly into the body, you have space for heads and extension boards, and the entire solution fits under the low profile cover. With its low profile cover, MaticBox has one of the smallest profiles on the market. If you would like to add larger extension boards, MaticBox comes with a taller automation cover, which provides extra space for larger elements such as relays, connectors, and large capacitors. Check out the links in the description to find out more. Flipping the fan and running the tests again shows no difference compared to the case when the fan is clicked directly into the case's body. The temperature is again maintained at around 60 degrees. Please note that this is full 100% CPU load, and the fan still maintains the temperature far lower than the critical 83 degrees. If you're still interested in running a larger fan, you can follow the links in the description where we compare different fans installed in the case up to large blower type fans for several applications. MaticBox's fan adapter can also be rotated 180 degrees in case you need some extra space for heads or extension boards. We've run the tests again with rotated fan adapter to see if there will be a difference in the temperatures. As it turns out, there were no significant differences, with the processor temperature staying again at around 60 degrees. Of course, in everyday applications, it will be rare to reach 100% CPU load. So in conclusion, all fan configurations work well in keeping the processor way below the critical 83 degrees. If you're using Raspberry Pi as a desktop computer, generally you will not need a fan, as demonstrated by the test at the beginning. If you would like to use the Pi for server applications, MaticBox is the perfect case, since it allows you to stack cases to form clusters. In these scenarios, blower type fans are a great cooling option, as they will push the hot air through the opening on the side of the case. Thank you for taking the time to watch this video. If you like this type of content, please consider subscribing to the channel. Until next time!